Hello everyone, this is a Gamewell-FCI S3 fire alarm control panel. These were first produced in the early 2010s and are designed for small to medium-sized facilities. Like the older and larger E3, the S3 is designed to be a convenient replacement for legacy FCI and Gamewell panels. This panel could run clip and velocity protocols, replacing older 7200 and 7100 panels, as well as XP95 for Gamewell Identiflex series panels. The S3 included an LCD touchscreen, 5 programmable user buttons, and support for up to 1 or 2 SLC loops. Option modules included a variety of annunciators, a DAC communicator, and network cards. So let's jump right into this. For this demonstration, the S3 will be running velocity devices. These include an MS7 AF pole station, an MS7S pole station with an AMM2I monitor module behind it, an ATD L3 heat detector, an ASD PL3R smoke detector with a system sensor B200WH LF low frequency sounder, and a system sensor spectral and advanced horn strobe with a low frequency sounder. So without further ado, let's begin. Silence that. The LED on the pole station took a while to latch red. Pretty strange, considering velocity is very similar to Notifier's flash scan protocol, where pole stations pull very fast, but it seems with velocity and these type of panels, everything is generally a lot slower. Now let's test this heat detector. Real quick, we'll reset the pole stations. Let the heat detector cool off. Now to test this smoke detector. Once it alarms, the low frequency sounder base will also activate. Unfortunately, because this panel isn't easy to program, the sounder base will keep sounding until the panel is reset, so we'll smoke it out, then reset, and maybe clean it out while it's resetting. So, cleaned out the smoke detector when the panel resets. Anytime a system reset happens, the panel has a 60-second initialization delay. But after waiting, it's back to normal. So the touchscreen, it's a pretty standard touchscreen. So compared to some other panels like the Simplex Verizon 70S or even the newer Notifier Inspire series, these aren't the best, but they're okay. These 5 user buttons are custom programmed. This can only be done through the PC programming software CamWorks, which is proprietary. But anyways, there's a drill button here. Start a fire drill real quick. The S3 panels use a B-Slim size cabinet. The E3 also uses this cabinet for smaller systems, and later Identiflex and 7100 panels also use this cabinet, which makes retrofits a lot easier. There's the label for the manufacture date and for the cabinet, SLP BLK. There's also red cabinets as well. So label. Back here is the LCD SLP, the touchscreen and display interface. And this here is the key lock connection here to lock out the controls. The LCD SLP and all other displays used with the S3 and E3 panels can be used as a local display, as seen here, or as an annunciator. For local applications, the display connects via a ribbon cable to the main board. But for remote applications, the terminal blocks here will provide power and communications. The S3 panels use the FLP-S7 power supply. This is the same power supply used in some Firelight panels like the MS10UD and the MS9600 UDLS. The main difference is just the connector to the main board. So AC input here, and batteries connect to the main board, and those are down there. The SLP E3 is the main board for the S3 panels. It stores the panel's configuration, controls the system, and also has various terminal blocks for wiring connections. At the top here are the signal circuits. These can be either 4 Class B circuits or 2 Class A circuits. There's a piezo right here. There's also one inside the display. Some very simple operator controls on the board itself, as well as indicators. These can be used if the S3 is a displayless panel. On the side, there's a couple of relays here, alarm trouble supervisory, an RS-485 interface for remote annunciators, and there's a switch here for RS-485 termination. This is for supervision. Next is auxiliary power and a municipal box, resettable and non-resettable. There's some jumpers down here to set the municipal box output as either reverse polarity or a municipal box releasing solenoid. As mentioned previously, this ribbon cable is for any local displays like the touchscreen display there. There's a ribbon connector up here for a network card, an Ethernet port, and an RS-232 terminal block for connection to a PC. At the top right are the slots for SLC cards, the SLC PM, which has clip or velocity protocol, and the SLC 95 PM, which has the XP95 protocol. On the S3, the SLC cards must be the same type, so an SLC PM cannot be mixed with the SLC 95 PM. Towards the bottom of the board are some dip switches. Switches 1 and 2 disable the SLC loops. Switch 1 disables loop 1, switch 2 disables loop 2. Switch 3 disables the signal circuits. Switch 4 disables the panel's internal piezo. And switch 5 sets the baud rate for the RS-232 port. You can either use a fixed rate or whatever is set in programming. Now let's take a look at the menu interface on the S3. So there's a couple of options here. Clock and enter a passcode. And then the time can be set right here. Info contains basic information about the system. Here is the basic information about the main board firmware and the configuration. This panel was set via auto program, as the CamWorks software is proprietary. Hardware info. So you have system, battery, and charger voltages, charger current, and the single circuit resistance values. The S3 is designed to accept a variety of different end-of-line resistor values for retrofit purposes. And then info about the touchscreen display. Now let's check out logs. Enter level 2 passcode. So there's options to print the log if there's a printer installed, or view the log. Just a couple of events here. You can also clear the log, and it'll reset the system. There's miscellaneous options. That's a level 1 again. So there's option to set the baud rate for the RS-232 port, sensitivity print, and reboot the system. Check out input-output, level 2. So there's device enable disable, just pick a device. There's also output control. Do loop 1, let's do address 2, and on. And it turns on the LEDs for that device. You can turn this one on, and I'll also turn the sounder base on. So we'll try to avoid that. Next is walk and drill. So there's fire drill and then walk test, audible or silent. And last is configure. There's two options here. Clear and reconfigure, which wipes the entire database and starts a new one. Or update SLC, which just updates the points on the SLC loops. The configure options are locked under level 4. In almost every case, unless the panel is brand new, that code will be changed as required in Gamewworks. Luckily, there is a backdoor for these panels and the E3, which utilizes the RS-232 port to show the level 4 passcode. And that is all for the Gamewell-FCI S3. As of recording, these panels are still in production. Like the E3, the S3's programming is restricted to the Gamewworks software, which means most advanced programming options are unavailable to anyone but licensed technicians. Many options like strobe synchronization on the signal circuits, individual point programming, and networking options, amongst many others. Therefore, if you happen to acquire one of these panels, while they can provide a basic fire alarm system, the more advanced features of the S3 cannot be used without access to Gamewworks. For those interested in running velocity devices, there are a few alternatives. The GWF-7075 is slightly less restrictive. There's also the Identiflex 100, which is fully programmable, but uncommon and very simple. In the end, there aren't many panels that run velocity protocol that are accessible to hobbyists, and it may be better to find a less restrictive alternative. In any case, if you have any questions or comments on the S3, feel free to post them below. But until next time, have a nice day.